All right, welcome to Math 60. This is the video lecture for section 1.2. This section is about combining like terms in mathematical expressions. So in math, we often have a lot of numbers and variables all existing in the same expression, and sometimes things can get very long, and we just want to combine them to get things shorter. So as an example, to start, I could write a number that looks like 13 plus 2 minus 5 plus 4 plus 8 minus 3. Now that's a number, but it's kind of spread out a lot. So it would make more sense to combine all these individual numbers to give me a single number. 13 and 2 makes 15, minus 5 makes 10, plus 4 makes 14, plus 8 makes 22, minus 3 makes 19. So I have combined all the numbers into a single number. It has the exact same mathematical content, but it sure is a lot easier to read, and it's a lot easier to do other things with. And in the last section, when we studied variables, we can combine numbers and we can also combine variables as long as those variables are what are called like terms. Like terms refer to variables represented by the same letter with the same exponent. So quick refresher on what an exponent is. An exponent is also known as a power. It is the number of times a mathematical object, like a number, e.g. a number or a variable, is multiplied by itself. 2 to the 5th means you multiply 2 by itself 5 times. And that right there, that 5, that's the exponent. X cubed means you're going to multiply x by itself 3 times. And that 3 right there is the exponent. So like terms have the same letter and the same exponent. Also, all basic numbers are like terms. So let me just give you a couple examples of combining like terms. Let's combine the like terms in the expression three x plus 10x minus 5 plus 4x minus 13x squared plus 2x squared plus 7. This is an example of simplifying, so I'll go ahead and rewrite. So this might be the question you get. And so often I will write the question and then I will write how I would approach it, which is why I usually rewrite this piece. So I'm rewriting it, checking as I go because it's really easy to change a plus to a minus or to forget a power. All right, so let's find our like terms. Here's an x term, here's an x term, here's an x term. Ah, see, I forgot that power right there. Now, these terms have x's, but the powers aren't the same. So they're different like terms. And then the -5 and the 7, those are numbers. And so those are like terms. So I'm going to go ahead actually and reorganize things before I start combining. You can choose to do that or not. It usually depends on how complicated the expression is you're working with. This one's complicated enough that I'm going to reorganize to put all my like terms together before I do the mathematical operations. I have a 3x, a 10x, and a 4x, and they're all positive. And then I have a minus 13x squared and a positive 2x squared. And then I have a -5 and a +7. And this can help me stay a little bit more organized when combining like terms. Doesn't really matter which like terms you put first in an expression, but commonly we put the largest powers first. So I'm going to rewrite this one more time with the largest powers on the variable first, and then the next largest powers, and then just the numbers that don't have any of the variables. And now I can do my mathematical work. So minus 13x squared plus 2x squared. These are like terms, so I can combine the minus 13 and the positive 2. Minus 13 plus 2 is negative 11, so I get negative 11x squared. Then I have a bunch of x terms. I have a 3, a 10, and a 4. So that's 13 and 4 is 17. So then I'll have 17x. And finally, -5 and +7 gives me +2. And I'm done. I can't combine the x squared term with the x term. And I can't combine the number, which is called a constant. I can't combine the number with either of those. So I've combined all of the like expressions, all of the like terms in this expression. Okay. What if we have not just different powers, but also different variables? So let's combine like terms in the expression 3x squared plus 7x minus 2y plus x squared minus y cubed plus 4. So I'll rewrite to get my work started. And let me identify the different terms. I have a 3x squared here, and I have another x squared there. A 7x, that's the only term with an x with no power on it. The minus 2y, That's the only y term with no power on it. And then I have the y cubed by itself and the 4 by itself. You don't have to use these little mnemonic symbols, but I'm just doing it to kind of highlight the different terms. So if I'm going to rewrite this, I have a 3x squared plus an x squared, and then I have a plus 7x, and then I have a minus y cubed. I'll put that one before the other because the power is bigger, and a minus 2y, and then a plus 4. And hopefully what you recognize is even though there's a lot of x's and a lot of y's floating around in this expression, only 2 of all of those are like terms, the 3x squared and the 4x squared. And we are not able to combine any of the other terms because they are not like terms. So now we're done. One word of caution, combining like terms is possible, but it doesn't mean the operations are necessarily simple. So let me show you an example of that. Let's combine like terms. Let's combine in the following. We'll have 1.3x squared plus 7/2 x squared plus y cubed minus 19/7 y cubed plus 8. So if I rewrite this, to start my work, I can see that I have 2x squared terms and 2y cubed terms and a constant. But combining 1.3 and 7/2 isn't always super simple. What you can do is you can grab your calculator if you want to convert the 7/2 into a decimal. And then you can use your calculator to add up the decimals. 7/2 converts to 3.5. Same thing here with this y cubed. Oops. Yes, positive y cubed. You can grab your calculator. I'm going to do it real quick off screen. Figure out what 19/7 is. It's 2.714 approximately. And this is also a good chance to show you what I do when I run out of room on a line is I move down below like that to keep track of my work, and the plus 8 at the back. Or I rewrite the whole thing and squish this part more. Now I can combine these two decimal versions, 1.3 and 3.5. That's going to be 4.8 x squared. 1y cubed minus 2.714y cubed. That's a good chance to grab the calculator to help out with that. Is minus wait. About minus 1.714 y cubed plus 8. And we have now combined those like terms. Combining like terms doesn't mean the mathematical operations are necessarily easy. That's the end of section 1.2. Next video will be on section 1.3.